Sir, good morning, sir. Good morning, everyone. I'm M. Ramkumar here. So I feel great privilege in giving a brief introduction about Dr. Lebes Dennis, Chief Technology Officer, Integrity Tech Solutions Private Limited. So after completion of his master's in computer applications from Bharathidasan University, Trichy, in the year 2000, he founded Integrity Solutions and holds an advanced postgraduate research degree, MPhil in Computer Science from Bharathidasan University, and a PhD in Computer Science from Bharat University, Chennai. As a seasoned technology executive, he brings 20 years of technical turnkey project management and development experience with strong core strategic, analytical, and interpersonal skills, with ability to define vision, strategy, and roadmap product development, mobility, enterprise web application, business intelligence, data analytics, business operations, and product marketing. So he specializes in defining cutting-edge products and services and implementation of turnkey project for diverse domains, which include a wide variety of leading institutions across defense, engineering, e-governance, financial, energy and utilities, retail, ERP for metal, mineral mining, banking, cash logistics operations, ATM operations, education and manufacturing with cutting-edge techno solutions such as SCADA, precision agriculture tech, intelligent water management solutions, data analytics, artificial intelligence, and ML. So now the topic which is going to be covered is global ATM reconciliation error codes mapping for all OEM manufacturers with common codes for rectification and reconciliation using artificial intelligence. And the next one is IoT and artificial intelligence based architecture for banking, cash logistics, and ATM operations with sensors based networks. Sir, now the session is yours, and so you can continue. Thank you.
Thank you, Ramkumar.
Thank you, sir. Thank you, sir.
Good morning to all of you, and it gives me immense pleasure today to connect myself with the academia, and would like to present today a webinar, AI and IoT in Global ATM Reconciliation. And I would start with my profile, which Ramkumar has already given to all of you. And I would like to just emphasize on certain areas which we are going to look into today. The major focus of today's seminar or the webinar is going to be on artificial intelligence and machine learning, and how that is being implemented in the banking, ATM, and other scenarios. So I would be taking you through today into a detailed of all these areas, so that it gives you a full clarity. So I would request each one of you to be inclined in the whole presentation in order to you grasp the areas which we are talking about. I would especially today work on the red line of the presentation which says about banking, cash logistics. There are areas which I have worked on 20 years of my experience in IT after completion of MC, and these are different domains on which my experience as an architect, as a founder, as a CEO of the IT company, I have been working on. So I believe today we will be looking into the AI/ML of ATM and banking. I also like to present to you about the various international journals which have been published by me. Being in industry for about 20 years, I also had a great flair in the academic area, and with which I pursued my MPhil and PhD while being in business, and being into cutting edge. And if you see my 6 recent papers which I've published, which are on the international, Web of Science, which comes on under the Scopus listed journals, and all of them have got a very good impact factor in terms of the impact factor of 1.7 or 10.22. And so this is just to give a brief idea about the area that we are today going to work on. All these 6 papers are on the cash logistics, ATM, and the whole life cycle of cash management, and which will give you a brief idea about what really you can Google around, and you can also see that in Scopus by using my name as the author name. Let's start the day today, and we'll look into artificial intelligence. I'm sure most of you would have really been, given insights on artificial intelligence by many of the people. And I would like to take you today to a different field of AI, which is being implemented into banking and ATM operations. I would start with the basic definition of what artificial intelligence is. So it's a wide-ranging branch of computer science concerned with building smart machines capable of performing tasks that typically require human intelligence. So basically, we are trying to imbibe this AI into ATM, which is a junk box. But I would be taking you through as to how we are working on the AI part of the programming in terms of the ATM applications that we have built. And I'll be exposing you today in terms of all the ATM technologies that are working today in the world around. So, so there is a reason for this advancing AI to come into ATM industry. If you see the deployment of ATMs in India, we have around 215,000 ATMs. And if you look worldwide, we have 41 lakh ATM installations in 195 countries of the world. So there are 8 major manufacturers, I would say around 6 of them, who occupy 95% of the market share of these ATM equipments, which we other words call original equipment manufacturers, or OEM. So in order to bring an AI into all this together, you understand the industry landscape in such a way that each manufacturer is into a different level of automation, depending on the country, the geography they are implementing, and therefore it becomes difficult to bring all of these platforms into a single platform of AI. So we are going to look today as to how this AI is going to, work on different applications. In general principle, most of us are aware about AI working on Google, which works on Siri, in the search of Google, Alexa, self-driving cars, and IBM's Watson. So these are things which we all really know. How do we implement this into ATM is what we are going to do. Let me take you to the next programming requirement that is there for AI, which we generally work on with machine language. So I would say a definition of machine learning is to study of computer algorithms that improve automatically through experience. It is seen as a subset of artificial intelligence. So any programming in terms of ATM or cash logistics or banking, and you require AI to be brought into, this requires confluence of 4 things together. One is a big data, from where you draw the data. Another is an artificial intelligence that you are trying to run over that big data. And you require a language, which is a machine learning language, which can really implement those algorithms that you work on AI. And the whole landscape of this works around these 4 jargons of big data, artificial intelligence, machine learning, and so I would like to draw you to the this thing about how big data is important to this particular field. Big data is the field that treats way to analyze, systematically extract information from, or otherwise deal with data sets that are too long or complex to be dealt with by traditional data processing applications. Now let's try to explain this jargon of big data in terms of ATM and cash logistics. we have seen is in the ATM industry and in the cash logistics industry and banking, the majority of these banks are using different softwares. So somebody is using, I would be taking you through those slides where we will be talking about what software application is used by these banks. But to just draw to your attention as to how do we call this as a big data, is I'd like to give an example. If we start with an ATM deployment pan-India, around 215,000 ATMs, which are shared by around 45 different banks, and each bank is running its own software. So you tend to get data from different platforms. Certain databases work on Oracle, certain work on MySQL, certain work on Plex, and certain works on mainframe. Certain people work on Postgres. So depending on each company or each bank, there are different softwares which are being used, and the database are different. Unless you bring everything together into one platform and mine this data, you will not be able to achieve the AI and ML. Therefore, big data is playing a bigger role in terms of bringing the automation part of AI and ML in banking and ATM industry. Now, how big is this data? Now, if you have to analyze, out of this 215,000 ATMs across India, there are approximately every day around 1,000 walk-ins in an ATM. So now this 1,000 translates into 215,000 is the data that we're talking about. So just multiply 2 lakh into 1,000. So we're talking about 45 crore data per day. That is a transaction level. And from where we have to do the data mining. And so this becomes a big data to handle. And this is for one day. You keep consolidating it for 30 days, you come to a million and a billion figure. And you move it to a year that runs into much of zettabytes, which we need to handle in big data. So our topic today, which is more towards AI, is connected with different fields. That is what I'm trying to draw to all of you today, is that there is a big data and there is a ML language which is trying to program itself into this big data using certain algorithms which we implement using AI. So there are now 3 different subjects which are before you. And there is an industry which has its own problems. Say, for instance, ATM industry, banking industry, these all have their own problems. So now we are trying to address these 4 different parameters of a project. Unless the user understands these 4 areas, he or she will not be able to imagine the work which has to be delivered and the key metrics that are required to build this kind of application. So let's move on. The next thing that we require, we call it as Internet of Things. That in terms of world's population, of the 50 billion machines and the equipments are available in 2020. And after COVID pandemic, what we have seen is we are more devised. Like today, we are attending a webinar, and I'm sure you are connected through devices. Each device has its own IP, it has its own MAC ID, and so do I am sitting somewhere in India, and we are all connected together in one network. So the concept of Internet of Things is that there are different things. These things can be defined as a sensor, can be an equipment, can be anything that can transfer its data over the internet network, can connect 2 hosts together, and is a thing, is going to be an IoT. So the Internet of Things is a system of integrated computer devices, which can be mechanical and digital machines provided with unique identifiers. When they say unique identifiers, this is what I'm trying to draw to you, that unique identification can be done by a MAC ID or by a IP. So that's what they are referring in a network without requiring human-to-human computer interactions. Now, we all came to a platform today where we have connected using Google, and we all are connected with our own machines. I'm sure we are not connecting by saying, what's your IP number? Please give me your IP number, I'll connect. So the interface that we are connected to today is what I call it as Internet of Things. So in 2020, as per the Cisco's predictions, we have around 6.58 devices per person who lives in this world, which means we have against each person. Like I'm connected to you today, I have my laptop in the front, I have my tablet on my left, I have my camera which is standing away about 2 feet away from a location from where it's trying to take me as a video. I have projected this in my monitor, which is something away on this side. And this is a device. Now, I am connecting you to different devices which are connecting under the single network today and trying to give basically so many devices connected together for one human being. This is what I'm trying to draw to all the audience today. So we are all connected today under one network, which is on IoT. A platform which is connecting us is Google. You call it Zoom, or you call it Cisco's webinar, or you call it as a a call of Google Meet, anything that you name it. But all of these are working based on an Internet of Things. So today we are talking about different devices connected to the world. So out of the 6.5 billion population of the world, today we have 50 billion equipments to connect with. So that's what we are trying to the problem. So now we have seen 4 different angles and a domain. One is what is AI. Another, we saw what is big data. The third thing that we saw is a language which we need to connect with this using ML. And the fourth thing that we are seeing is a framework or a platform or an Internet of Things. And the fifth thing that we saw is a domain in which we are entering. The domain I'm talking about here today is banking and ATM. So a confluence of these 5 things together is what is going to handle AI and ML in this industry. So let me draw you as to how does big data, AI, ML, IoT work in banking, cash logistics, ATM industry. And we're going to talk today only on this area. And I will take you to different slides where I'll be explaining you. I don't know how much I can explain on a webinar, but I'll make my best effort to put it in such a way that I'm able to reach all of you in the best possible way in which I can interact and teach you today on AI. So let's move in, and right before you, which is being thrown today right now, is a slide which explains to you on different core banking solutions used in different. And why I'm drawing you to this particular solution or this slide is to bring all the audience together to make them understand every bank is different from their policy, their framework, their software, their implementation, their. So let me get into the first row. Just please see with the first row there, which talks about ICICI Bank, IndusInd Bank, ING Vysya. So these are 3 banks. Bank of India, Bank of Baroda, and Punjab National Bank. Now, about 6 banks are using a software called Finacle, which is being developed by Infosys. Now, the framework, the database, the programming language is different for these 6 banks. And all these 6 banks have their own ATM equipment, have their own core banking application, have their own wholesale banking application. So we are trying to now touch 6 different banks having a similar Finacle in different versions of Finacle. Finacle has got different versions. So we need to first know which version, which bank is using, what is their framework, and how do we connect with them. So let me take you to the next slide where I'm talking about Deutsche Bank, State Bank of India, Allahabad Bank. These 3 banks are right now using a software called Banks, which is developed by TCS. Now, another row again, we move into Canara Bank, Yes Bank, Karur Vysya, which is using FlexCube of Oracle. Next, we go to Bank of America, Citibank, and Standard Chartered Bank, and these 3 banks are using FinOne, which is software being built by Nucleus Software, again a different enterprise. If you ask me what's the difference here, certain softwares are running on Java with Oracle. Certain softwares of them work on .NET with SQL Server. So you have, there is a sea of change between these softwares, the options that they bring, the solutions that they offer. Well, let's move into an international network where we talk about Omni Enterprise, which is running, which is doing for Corporation Bank. Then you have HSBC runs on Cobis Corp. RBS, that is Royal Bank of Scotland, runs on Sopra. So these are different languages that I'm talking about, that these are into different frameworks, different language, different databases, and we are trying to solve a problem using AI, ML, and big data and IoT. So first we need to know is to different banks using different applications. This is what we are drawing into this particular slide. I hope all of us are on the same page. Let me move to the next slide. Let's come into the ATM landscape in India. I will be taking you to the landscape of the world of ATM. First, let's start with India. We have around 54 banks in India, which is being classified as public sector 20, private sector 19, state bank group 6, and foreign bank 7. Now, whenever you build a software, you need to make sure that you are going to service 54 different applications which are working in the backend. Next is an MSP, we call managed service provider. A managed service provider, it is a link between the bank and the ATM. So if you see, you want to deploy an ATM has to be deployed in Mount Road, Chennai, or you are trying to draw this in Janpat Marg in Delhi. You require a place which has to be sourced. You require an electricity connection there. You require a real estate. You require a manpower. You require a lease line connection. You require a system there. And all these things cannot be done by bank. So there is a entity called managed service provider. What do they manage? They manage all these things which I said. So they people manage all these things. There are 16 MSPs in India who service this industry. And now once you source out all these things and banks take over the ATM, now we are working on the next level, wherein there is another agency called CRA or CLA. Both are same. And CLA refers to Cash Logistic Agency, CRA refers to the same, Cash Replenishment Agencies. So there are 9 major cash replenishment agencies in India. You can start with CMS Info Systems, SIS Prosecure, Writer Safeguard, RCMS, Logicash, Securitrans, Secure Value India, SSI, and Group 4. So these are the 9 different companies which manage the cash replenishment across these 215,000 ATMs in India. And now if you come to ATM classification in India, we have around, as I said, 225,000 ATMs. So there are classifications inside. So let me explain. There are 113,350 ATMs which are on-site. When I say on-site, on-site means something that you have a bank and the bank branch has an ATM inside the branch or outside the branch, which is directly connected to the branch. So which are called on-site ATMs. So wherever you go, if the ATM is near to the branch, on the premises of the branch, we call it as on-site ATM. There are off-site ATM, which means there is no connectivity between the branch. This is located somewhere on the highway, somewhere around the city, where you have mall. So anywhere it can be. So we call it as off-site ATM. So this two comprise together of 210,000 ATMs, which are in bank and off-site and on-site. There are white label ATMs we call. These are ATMs which can be managed by any of the company which has got license to do. Not necessarily that they should be banks, like Tata also has white label. So Tata, though they are not a bank, they still run ATMs which are white label. So there are many companies like this which run white label. So there are around 15,000 white label ATMs in India. So overall count, we have 225,000 ATMs in India. Now when I said IoT, I'm also referring to you that one ATM is at one IoT. It has a MAC ID, it has a IP address, you can configure, you can connect with it. So this is the ATM landscape that I'm trying to refer to you all so that you get into an understanding. I'm trying to take you into IoT, the AI, ML. Before that, I'm trying to take you through the landscape so that you understand that this is the industry that we are stepping in. And I hope, let's talk about the cash economy. If you have to really know what is the size of this cash in Indian economy through the ATM and the cash logistics route. About, I would say, 11.4% of the total GDP, the gross domestic product of India, is the cash component that we're talking about. The ratio of the currency in circulation is 11.4% of the GDP. To make it in a simpler terms, if I have to explain what is this, if there is total GDP about 1 lakh, I'm just giving a rough example, then 11,000 rupees is the cash in circulation, which means this 11.4% of cash rolls 11.4% times, multiplies itself to achieve that particular GDP which we're talking about. So that's what is the ratio of currency in circulation while you compare with GDP. Now let me draw you to the next this thing. The supply of money is depending on the elasticity of demand for money. So year on year, there is an increase. Right now, after demonetization, there is a 16.6% increase in currency in circulation. And if you see cash to GDP ratio of US, it's 7.9, and EU, if you say, it is 10.6. Typically, when you come to India's transaction level of cash, there is 95% of the transactions which are done across India is under cash. So still, cash dominates the whole market. So if you look into that, we have many aspects of saying, you know, we are digital India, Paytm, we have cards and all those things. We only form 5% of India's market. 95% of India's market runs on cash. So how do I know? Because I work on cash management. One of my project is cash management. The project in which I worked about 11 years as an architect and as a consultant who gives the whole scope of business and as to how to move it in terms of ATM, in terms of cash logistics were handled by me. So I understand this industry quite well. So let me take you to the next metrics of ATM, key metrics. Now, there are 1, 2, 3, 4, 5, about 10 key metrics. Now, let me explain to you what I talk about here about metrics. These are too much to understand, given a point that I just have 90 minutes and I need to explain to you all in this 90 minutes. It will be prudent if I move faster, because these are some of the industry requirements before you move into automation. So always we have to keep in mind, which are self-explanatory, about 10 major issues or metrics that every bank and every ATM will look into before you are going into automation of AI. So the minimum level of expectation of the bank would be that you deliver this 10 and then you talk about AI. So that's what I'm trying to tell here. Okay, let's move to the size of business and how the ATM looks inside if you really open up an ATM. So that I can explain to you about how the ATM will look into in terms of the. Let's get into the global ATM market. Was valued about 20 billion, and if you really are trying to understand that in 2027 it's going to move to 30 billion. Billion is around 7,500 crore Indian. So that's the industry size of the alone, other than cash management. So which is growing on a annual gross ratio of about 5.2% from 2020 to 2027. That's the. If you see on the graph that depicts the ATM base of the world. So globally we have 44.1 million ATM installation. On the left side of the image, you are able to see the inside of an ATM. I will explain to you each part of this in my next slide. So now this is the industry. If you have to connect the ATM on an IoT, so this is how it has to be connected. Now you need to connect the wearable device, which is connected with the ATM admin. The guy who goes, opens the ATM and replenishes has to have a wearable device. We can connect through Wi-Fi, GSM, GPRS or 3G connection. There are NFC, RFID, QR, barcode readers, smartphone or LED and LCD screens that are there. You have to make sure that you are passing data through them. GPS system, you need to generate all this into a dashboard analytics. Handle EPOS machines, tablet and touch screens. There are ERP application servers, host-to-host server, bank servers. Then you have virtual private servers. Then you have cash vans. You have regional offices which has to be connected. You have to connect the ATM machine. You have to connect the collection executive or the custodians. And on the left, on the below, you see that the receipts which are being generated on ground has to be transmitted through this internet network, through GPS, through digital signature, EPOS, web services, ATM data, and live video. So this is the requirement that you require before you connect them into an AI-based network. So let's get into what is the ATM machine parts look like. I think we are at 12 now. I have another hour and I have 60 more slides. We're going good in time, I believe. So this is a typical diagrammatic explanation of how a machine part of ATM plays. And this is an ATM which really we embed this into a wall. So these are ATMs which are not standalone, which stands on a normal ATM machine that you see right now. So this is a module which can be inserted into a enclosure. So you have slot for lighting, invoice slot, card slot, receipt issue slot, cash slot, numeric pad, monitor, function keypad frame, and the through wall insert. And then you have dispenser, you have journal printer, safe door, you have instrument industrial PC, you have RS-232 hub, receipt printer, diagnostic unit, card reader, and user monitor. So these are typically forming part of an ATM machine. Now you also see an industrial PC. If you can see my mouse moving there, this is the industrial PC. And this is connected on the internet through a firewall equipment, which is software and hardware based, through which you generally connect this particular device to a network. To a cash logistic life cycle before you. These are the different cash logistic equipments or different life cycles. On one side, you have client banks. They send their request every day, and that has to be picked up from where, how much cash you have to pick up, and where you have to deliver. This goes through a network wherein C picks up the cash, generates the report, visits the deposits the bank, and that comes through the bank. The copy comes as a deposit scan to the receipt which is captured, and it goes to the regional enterprise data server from where all the data are captured and it is being sent back. You have vaults across India where these cash are kept. You have banking, second level of reconciliation, which happens in the head office. You have report from bank departments. You have region reconciliation of cash deposit. You have funding transfers done. All these things form a network. You have cash vans for cash in transit. You have armed guards who travel through this cash. There are GPS-based equipments fixed on these vans. They also have camera, which is connected, and this is monitored centrally in the vault management system. And in terms of alerts, the alerts are being sent by SMS or by notifications using Android and IoT. So this is the cash logistic life cycle, which I have really demonstrated before you. And let me. Now, if you take the different OEM manufacturers who are manufacturing this ATM equipment worldwide, these are the 6 major manufacturers who manufacture, which means you go to any country, you go to London, you will see only these equipments. You go to US, same equipment. Go to Africa, you see the same. You come to India, you see the same. These are the 6 major manufacturers of ATM which run all these equipments together. So one is called Diebold Nixdorf. which was earlier named as Wincor Nixdorf, which is a German-based company. Diebold is an American-based company which took over and they merged together and formed Diebold Nixdorf. NCR is again a US-based company which was called National Cash Register and which runs out of Atlanta, US. And then you have Hantel, which is from California. And you have from South Korea, you have Husong. And then you have Triton, which is again from US. You have Genmega, which is again from California. You see, majoritarily, you will come to understand that world ATMs are manufactured either by US companies or by South Korea. We don't have Chinese big operators who are capturing the world market. Chinese only manufacture ATMs that are operated only in China. So worldwide, these are the 6 major manufacturers which occupy 95% of the market, which is 4.1 million, 410,000 ATMs worldwide. I'm sorry, 41 lakh ATMs worldwide. So next, let me take you to next slide. Financial transaction based challenges that we face in this industry. So everything is self-explanatory. I would request you to kindly go through all this, which will clarify that this is a zero-error solution, utmost data security. Then you have end-of-day output based on banking system, which means you have to connect every solution to the end of the day with the banking software which is running. Then you have periodical information security audits, which means you will be audited by Information Security 2015, and ISMS, which is a standard 27001. And then you have incorporating client related data along with core operational data. Every client comes with their requirements of data to be given, and you also have your own data, which has to be put in for your listings. Then you have mission critical operation, which means 24/7. You cannot switch off anything. It is running 24/7, 365 days. And maintenance of private data center, you need to run a data center or you get into a cloud. Majority of the banks run their own data center, so I don't see anybody moving into cloud. Next, you have increase of data volume transactions and service demands of the clients. These are minimum financial transaction challenges that you need to build in your system. So let me take you to the next slide. ERP module-wise architecture. So this is something which we have built as ERP, which is running across India, CRAs and the MSPs who use this software. There are 4 + 4, 8 different modules and additional 6 more modules which run the whole of cash logistics. When I say DSB refers to doorstep, which includes ATM2. So we will also see the modules that we are working on. So there is a central repository application which runs the LOI and feasibility, operations, banking, billing and revenue assurance, human resource, NOC, which is Network Operations Center, Cash Van, and then we have dashboard and analytics. These are the languages that we generate. So I would like to give you some insights into this particular slide where we're talking about language. Basically, different languages are being used to build this. I would say around 70 different programming languages we have used to deliver this application. Some of them are before you. Like most of our terminal run on Linux. We use CentOS, run on PHP with MySQL as database. We also connect using jQuery, JAX, CSS, Apache. Then we use JavaScript, SQLite, Postgres, and XML. So whenever we do web services transactions where we have to transact data from one server to other server, we use the XML, and we also use SOAP. We also use web services. So on the left side, you see the programming language, which is on Angular, Node.js, with again Postgres, REST API we use, using Angular plus Node.js and Postgres SQL. So generally, an Angular program has got 4 components. When you write an Angular program, we use version 8 and above. So which runs 4 pages programming output. One is the HTML, then you have CSS, then you have TS, and you have spec.ts. So all the four together runs on CLI, the command line interface, and the program file is generated as an application build, which we directly build and deploy in our server. Unlike AngularJS, which works on MVC architecture, AngularJS works on component-based architecture. So we also work on Node.js, which is about version 12 and above, and then we have Nginx. We work on Postgres, which is 1.16. Use load balancers to balance the load of transactions which is coming to the server, which may be very high to handle in a normal course of. So let's move into the programming languages that we will be using while we build the same application using AI and ML. So let's move on. We work on Python, which is basically scientific programming language, which we use for the AI part of the program. And also we work with the Django, Flask, also the TensorFlow. We work on NumPy, Pandas, and SymPy. And all these things together form our programming languages, which we use really for the AI and ML. I'm giving you a brief outline about what we need to consider while we build these applications. One is that these are cross-browser, and these are cross-browser where this can run on different kinds of browsers which are there. The pages are self-explanatory. We work on 7.2 MVC with CodeIgniter and MariaDB 10.3. And Python with MariaDB we work on. Many of times when it is scientific programming, we use direct the Excels and CSVs, wherein we don't work on the databases there. Different databases connected on the big data terminal. From there we launch and we just run a Python and run it using Excel and CSS. And also we work on Bootstrap using Angular. I've given about LDAP, RBAC, the minimum requirements on Oracle, MariaDB, MySQL, and a different Django framework for Python, AngularJS, and this is how the whole programming. Also, we connect with the embedded system using handles, where we will be using Linux in C. We also use iOS. We also use Android. So all these things is a combinational programming language. That's why I said about 70 different languages we use in order to build this particular. Let me take to the infrastructure monitoring and analytics solutions. The one which you are seeing right now is the interface that we are using our infrastructure monitoring and analytics solutions. For the OS, the operating system part, we use Red Hat. We also use CentOS or Ubuntu. On the cloud, we can work with AWS, GCP, or Azure, which is on-premise. Most of our projects are on, and for virtualization, we use VMware or Zen, or we also use VirtualBox. For high availability, we have different models to use. If we are going on an open source model, we use DRBD, CoreSync, and also Pacemaker. And for storage, it can be on NFS or ISKC. And for staging and production, we use different frameworks. For containerization, we have two different models. One is Docker, another is Kubernetes. Depending on the client's backend deployment, if the client is on Kubernetes, we also prefer Kubernetes there. If it is on Docker, we go with Docker. And on automation management, we work Ansible. For infrastructure management, we use Terraform. And versioning control, we use GitHub, Bitbucket, or GitLab. So for continuous integration and continuous deployment, we use Jenkins. And for monitoring tools, we use Grafana, Prometheus, Grafana, Slack, all these things together. So I believe the whole architecture is clear enough to make you understand about what we are working here. What I've shown you there is on a VPN network. So we have DC1, that is data center 1, data center 2, and we also have on demand this DC is connected with around 1,000 different servers. So depending on the load that we connect, each server moves into the next level. I also now would give you a total picture about how the Kubernetes work with pull and push metrics using alerts. So we auto discover using Kubernetes. We push all the microservices, and using Prometheus, all the alerts which happens in server as to when it is working, when it is down, all these things are sent to our mobile using an app called Slack. So if you Google around about Slack, you will be able to understand what Slack is. So we work on Slack there, and this is our next infrastructure architecture, open source. As I previously told you about Pacemaker, CoroSync, and DRBD, these are the applications that we run on methodology using Linux in CentOS. And this is just a remote class one video surveillance monitoring. We have video walls in cash logistics and ATM. You will see a big wall, connected with around 100 to 100 monitors. Each monitor is monitoring a particular location. Like we monitor from here, Ahmedabad. So I have a server in Ahmedabad, which relays all the cash van inputs and the vault inputs video through a video analytic tool to this wall. So you are able to see from here what is happening in Ahmedabad. So you see that same thing you see for Ranchi, you see for Delhi, you for Chennai, for everywhere. So this is a video wall, which I'm trying to refer here, location 1 each wise. And these are now connected to different vaults. And this is through an NOC, we are able to see all this. This is the application operation structure of the same vault, which is self-explanatory. And next, what I would like to go is on central scan repositories architecture. Again, this is too deep to make you explain in a very short term, but however, I'll try to explain to you that there are storage servers which we have in different locations. On a multi-factor authentication code, each ATM or application DNS from where the host is making a request server goes through a firewall. In certain places, it would be Forcepoint, it would have been Sophos. So different firewalls we use through which it comes to a real network. And based on, after passing on the DMZ, that is demilitarized zone, you move into the server architecture. So there is a jumping host, which will keep sending you different host IDs, so that a hacker is not able to move inside and able to work on inside. So this slide is about ISMS policy. What I would like to draw to you here is about the different stringent rules which are formed by the banks while they do ISMS based audits. So these banks conduct different information security based audits which run on authentication and cryptography. So we have 3 levels of ISMS policy, which is for application layer, for the network layer, for the cyber security. We have a different cyber laws for that. And for network and for application, we have separate these things. So if you see identification, authentication of user, information classification, physical security, user interface and internet and email access, antivirus, firewall and software related controls, data backup storage, remote storage media, disaster recovery procedures and business continuity plans, and then you have security incident handling, and then you have general guidelines. All these things together form the policy with which we run the application. So if you build an AI and you build a ML program and it has to run on a server and you have to access these data, you need to pass your software with this ISMS policy, which is ISO 27001, and you also need to clear the ISMS for security, for cyber security. I'm trying to show you the different cybersecurity norms that these banks have led us in terms of security levels. You can see them in cyber attacks. To stop the attacks, they give us the minimum level of requirements to identify, protect, detect, respond, and recover. So these are the cybersecurity framework based on which all these banks, which are on the right side, on the left of mine, which are classified based on private banks, multinational banks, and government banks or public sector banks. They use the information security policy, which is a guideline given by RBI. And based on this, you need to meet all these criteria for your software to move into the next level. So let's come into ATM key management. If you look into ATM, I was talking about the ATM. Each ATM has a lock inside. The lock is not the room lock. The ATM, when you go and draw a cash, you use a user terminal. In that terminal, you generally give your card, you insert your card, you give your keypads. So this ATM, by an ATM user or by a company which is managing the ATM, they can put this ATM into admin mode. And there are two kinds of locks which are used worldwide. One is called Sergeant and Lieutenant, and next is called Kavamas. So these two locks I have shown you in this picture. These are the locks which can be remotely operated. And this remote operations is enabled using AI. I will take you through as to how these memory pins and the locks are connected with AI of the location where you are going and opening an ATM, the person who's taking the device, the person who's wearing the wearable device, how far is he from the ATM, and the GPS and latitude and longitude of that particular person, based on which these keys are opened remotely from a central location. So now I'm explaining this ATM key management in terms of a mobile app or by a one-time password. So you see that there is a person who is a knock user. There is a person who is managing this from the central server. So this central server, person moves into ATM machine and opens the SNG lock, requests from a mobile app that I want to have the admin password of the ATM to open the vault assets for the currency that is there in the ATM. So if he moves inside, he takes up the app. This app sends a data to the app server, and through that, there is a dial-up callback response through IVR, and there is a call launch pad which is sitting in the center, from where, before launching this, the system tells who is the person who's there right now in the ATM, what is his lat long, how far is he from the ATM, is he the same person who's holding the mobile app from where he is operating, and does he have the first level pin of that SNG lock. After verifying all these things, we find out that he is a real user. If there is a system doubt, there is an auto launcher call through IVR. It will go to a call and he has to give his voice and give his PIN using that voice call. After these three levels have gone, the ATM PIN is generated and given to them, through which they open the ATM for replenishment. So this is the architecture which we have now converted into an AI-based terminal. Previously, this was not possible using a normal mobile phone. So right now, we have embedded it with different terminals. We started taking the MAC ID, we started taking the IP address, we started taking the OTP, we started taking the GPS lat long, we started taking the location from where, the distance he traveled from there. We started taking the distance from the cached Jeep or cached van, how far is he standing. When you have all these parameters as true, the system allows the password to go to him on an automatic mode, which is an AI-enabled system. And this is what we are trying to explain to you in this. Let me draw you to the next slide, which talks about the global ATM network and AI integration as to how we did. Right now, if you see the ATM global network, the major network that is being connected. Now, how do we see? See, as we have connected today on this Google Meet, it's the same way with which ATMs are connected in the world. On the left side, I have given the different names of these operators or the manufacturers. It says Diebold Mix 4. Next is NCR. Next, I'm showing you Hosong. So any brand of ATM which is fixed anywhere in the world, they transmit data on a HTTPS route using XML or a REST-based APIs. These are now connected to a terminal transaction management switch, which happens inside a bank's gateway. And they have cash management, reporting analysis, we have promotion advertising, you have issue of SLA and everything together in the core banking. And then all these things together are connected through a gateway, through Visa, Master, or any other connectivity which has ISO 8583 specifications to it. So you may use a switch which may call as base 24. So we use all the multiple bridges across the world. So through which, if you have a credit card or a debit card of a ICICI bank, and you are right now in Amsterdam, you got down in Amsterdam and you wanted to now withdraw 100 euro. Now the ATMs in Amsterdam will send this data to your host bank server in order to find out, do you really have $100 or 100 currency, whichever is equivalent. If you have equivalent pounds or euro. So if you calculate that to Indian money, 10,000, this data will come to the terminal transaction server, connect with Indian bank, and send a value back to the ATM saying, yes, he has the money, please release it. And this is authorized by Visa. So you withdraw the money, and this transaction immediately is debited into India's ICICI Bank. This network is what I'm talking about, is about ATM Global Network. So on the right, you see baseline cybersecurity controls for ATM switch application service providers. So any service provider who wants to do an ATM switch has got the following all transaction connectivity. You need to make sure that he gives prevention access of unauthorized software, strengthening environment controls, compliance with various standards, advanced real-time threat defense and management, forensics, vulnerability assessment and penetration test, setting up a cybersecurity SOC. Then you give incident response, then you give audit logs. All these things you need to connect in your server and software, connect with the global network, and make sure that you are coming in equivalence to what they are requirements for you to be application service provider for ATM. So we have dealt all these things together, built this as a network, and brought that into our systems, and that's what I'm today showing you some screens out of it. Let's get into the algorithms that are being used. We are using different kinds of algorithms in terms of the AI and ML. Again, would like to take you through the algorithms that are used in unsupervised learning, supervised learning, and reinforced learning. So depending on what application we are using for that particular instance, we use these algorithms. Basic algorithm that we are using right now in our systems, I would like to show you, is decision tree algorithm. Whenever you want a branching method to illustrate every possible outcome of a decision you want to track, we use decision tree. There is a naive base classifying algorithm, which is on the Bayes theorem, which we use whenever a value of independent of another value, and you want to predict this value. So we use Bayes during that time. Then there is a clustering algorithm that we used when we use the unsupervised learning, and clustering methods are typically organized by the modeling approach such as centroid based and hierarchical. Then we use support vector machines algorithm, and then we use principal component analysis. Then we use artificial neural network algorithm, or in other words, we call it as reinforcement learning. And then we also do deep learning algorithms on a hierarchical learning or a structured learning. So these are different algorithms that we use typically when we want to run a particular, be it in an ATM, or be it in a branch, or be it in a cash logistics, or be it in an MSP. So in all these places, these are running as an application. It can be for robot navigation, it can be for targeted marketing. Depending on our application that we really want, we use all these algorithms. I've just just given a brief understanding and classification of this unsupervised learning and supervised learning. How do we, run this, and how do we run our classification or regression in this decision tree, or in data when data is too large, or data you require speed and accuracy. So these are topics which we use for modeling, and this is how we use the models for application. This is all self-explanatory types of learning that we use, and depending on where do we use. So I'll be taking to you 6 specific on AI and where do we use this AI in ATM. The next slides, which will briefly take you through as to why we use this, how do we use this, and what is the outcome of this, and why do industry require this as a problem. So what we need to understand is that it is not based on our imaginations that we can run an AI. There are set specific objectives. There has to be a problem statement. Industry should require it because it is commercial. At last, you run this, you need to sell it to a company. The company has to buy your software. There has to be some merit and weightage to it. It all depends on how do you market this to them. And to market that, you really require different applications to work with. So now let me take you to reconciliation management of an ATM. Now, I have another 30 minutes, if I'm not wrong, before I end my session. And I have 40 more slides to go. I think I need to rush. I'll keep moving as I explain. So basically, what is reconciliation in ATM? While we see ATMs in the whole world, just imagine India's deployment of ATM. India's deployment of ATM, if you take SBI, State Bank of India, out of 225,000 ATMs, State Bank of India has 45,000 ATMs in India. Now, these 45,000 ATMs are located across India. In every different geography of India, you have State Bank's ATM. Now, imagine the State Bank server. Now, all these ATMs are talking to the, we call that host. These are all hosts. They are talking to a centralized ATM command server. So, when an ATM is a dumb machine, unlike how we think, ATM does not know what to do. ATM just has key register. So when I open an ATM on a admin mode, I'm trying to open an ATM, and I'm trying to see how much cash is there in each cassettes. So as you have a standard drawer in your cupboard or in your table, the same way ATM has standard cassettes. So there will be around 4 cassettes, 5 cassettes, 6 cassettes, depending on. Majority of Indian ATMs have got 4 cassettes. The 4 cassettes are because that you want to keep 2,000 rupee note for one cassette. Then you have 200 rupee note for another cassette, 100 rupees note for another cassette, and 50 rupees note for another cassette. The same for another bank will be different. They will keep 500, 2,000, 100, and they may avoid 50 also. So depending on the deployment of your ATM, these notes are defined as to what you need to calibrate that ATM for. Now, when I load this cash inside, there is a key register which I am keying from my fingers, and I'm saying I have just loaded 30 lakhs Indian money inside this ATM. ATM does not have any mechanism to identify if I have the amount what I'm keying inside is the same amount which is there in ATM. So there is a different mechanism through which we enter. So we just enter and say, I've kept 2,000 rupee note, 100, which is 2 lakhs. I've kept 500 notes, 10,000, which is around 5 lakhs or 5 crores. So that's how I enter everything and I finish it. This data goes to the server. So there are people who are withdrawing cash after this. The ATM can malfunction. It can take the cash into a divert tray where you'll not really know how much cash was withdrawn, what is not withdrawn. All these things together has to be reconciled at the day end. So this is the reconciliation management which we speak in ATM. The reconciliation of ATM runs based on how much was the journal entry made in the ATM, how much was the switch value or the server value of the bank, how much was the gateway server switch, which was in US, or Visa or Master switch, which says this much money was transacted. So these are three different legs of that reconciliation. And the fourth leg is the physical cash, which that person is handling. When there is a variation between these four, there is a reconciliation has to be run in order to find out who's correct and who's not correct. That is what we refer to as reconciliation of ATM. Now, I have just briefly given the next slide. This reconciliation has to run between MSP, CRA, and bank. And this can be done need is money. If there is a variation, the ATM says, today I dispensed 50 lakhs. Inside, when you open the cash tray, you say it has dispensed only 40 lakhs. There is a difference of 10 lakhs. Make sure this reconciliation is done on that night, closed, and then the next day started. That's why we call EOD, end of day. Next is handling of ATM. It will be too deep for me to move inside. Let me take the next. Time-consuming activity. Data is not always standardized using multiple and complex financial transit instrument. So these are different things which are parameters which really make it more difficult for us to get into the reconciliation services. So let me explain to you parties which are involved on ATM. One is the card holder, card issuer. Your card holder is a person whom the plastic card has been given. Supposing it's me, I'm the card holder. Card issuer is the bank which has issued the card. If I have my account with ICICI Bank is the card issuer. Acquirer is the person who owns the ATM. If I go and put this ATM card in an SBI ATM, that becomes acquirer. The next is acquirer processes request and transact originates from ATM's third party, and it automatically goes to the bank from where it is authorizes, and then it gives. There are classification of ATM transactions. Honest transaction is if my card, ICICI, was inserted in our ATM, ICICI ATM, it's on transaction. Remote honest transaction, it can be somebody's machine, but our card. Somebody's bank, our card. And the fourth one is not on us transactions. Transactions which are remote, which happens in some other bank overseas and some other card, but we are the acquirer. There are four aspects of reconciliation that we can see. Expected physical cash in the machine at any point of given time. Anytime an Indian ATM can keep max to 80 lakhs of cash in one ATM on the cassette that we are configuring to. So how much physical cash should be there at any given point of time is the physical cash in the machine. To complete the cash offload of the ATM machine, expected physical cash. Now when you offload the next cash, how much the physical cash should be there after you offload. Determine if there is an overage or a shortage. Depending on if there is a shortage, you need to identify what is the reason for shortage. If there is an overage, which means high. Supposing you put up your card, you just give 10,000 and that particular transaction did not happen. So that particular money would be lying in the divert tray. So this is overage, which will be more than what is drawn will be there inside the ATM. To determine if there's a cash theft in the ATM machine, you can also do a theft in ATM, which I'll be dealing in cyber and other security as to how ATM thefts happen. So we need to do loading, validation, and matching. These are the four areas through which we do the reconciliation of an ATM. So this particular physical done is now done using a software, using an artificial intelligence and a neural network in which machine does all these things and it tells us exactly what happened on ground. This was not possible about 3 years back, but in the last 3 years, we have started doing this using AI, ML, and big data with IoT. So this is a life cycle of an ATM. Why failure, how the ATM failed, when it failed, and what was failed in that ATM. How a machine aspect has been drawn. There can be three kinds of queries which can come. It can be customer dispute. You as a customer give a complaint to your bank stating, I lost 50,000 while withdrawing cash in your ATM. It can be an overage and shortage in ATM handlings. It can be a reporting of queries. So this is based on the EJ, which is electronic journal, which we pull out of the ATM. And mismatch between physical cash and EJ. and yesterday's closing and today's opening. All these things are reasons for reporting queries. There is something called CBR related queries, cash balancing reconciliation required queries, and switch counter request. When I say switch, it is base 24, which is in US, and bank's central server, NOC, and the ATM at the end. This is the ATM reporting architecture, which is again self-explanatory. Bank server through firewall is connected to an IPS internet connection, secured wired. ATM switch goes to ATM machine. Same way, mobile app, which is used by ATM custodian, the CBR ATM switch report, ATM JV report is being transacted through this mobile app to the ATM machine, again back to the through a GPRS network, through an internet, through an IPS firewall to the active and primary and secondary production servers, ATM server, to the head office, to regional bank and a branch and a risk assessment team. This is the whole reporting architecture. And these are the modules that we use for reconciliation ATM. And I said honest, issuer, and acquire. These can be different proprietary software or RuPay or MX or Visa or Masters through which this has to be done. And let's come to the next chapter of where we really do the GPS or route mapping using the AI and ML. So the AI ML software that we are using for GPS route mapping is based on the right side below. You are seeing a different pink color installations. Each pink of them is the location where we need to do a service or ATM deployed location. Green is the route through which you are trying to approach that particular location. And blue is the person who is a technician who will go and do the service or entering into a response. So this is how the whole ATM network runs. So we have different routes under which the GPS lat long of every Jeep, every custodian, and the ATM are matched together, and using Digits algorithm, the shortest path on the traveling salesman problem, we arrive at a route through which an ATM should move and be replenished or filled with cash through a GPS route mapping Jeep or a custodian with the cash. So these are the routes on which it has to travel, and based on what algorithm is what we have given on the left side. So this will make all the routes in the minimum possible way. By doing one traverse, you will be able to capture maximum ATMs in that particular route. So when we go for a vault opening on an ATM route, the wearable device, which is with the cash custodian, will give him GPS data, will also give us the data that how far he is running, how will he handle the Kabamas and Sergeant and Greenleaf locks, and how the OTP will be given to him in order to open the ATM into admin mode. So this is done using AI. This is the central switch of ATM worldwide network with which we connect the global ATM reconciliation codes. When I say reconciliation codes, for every error code that the OEM equipment generates, you have a separate listing. Supposing on a NCR machine, NCR ATM equipment, I withdraw 10,000 rupees. The ATM generates that, and before that cash comes out to the dispenser, my hand by mistake goes before the dispenser. So what happens is, I draw this cash which has come till the presenter, and due to the shadow which is being created through my hand, the system thinks that there is an obstruction to deliver this cash to you. So it generates a presenter error, which is 3032, and says cash dispensed. This is an inherent problem in that particular machine. Based on this error code, the AI picks up that number and identifies the reason for this cash loss or cash not dispensed, and generates in a master as to this was the problem which happened in Mount Road ATM number 4546 of ICICI during 10/20 of this date, and the customer card number was this. So this is what we are working on, global ATM error codes. For want of confidentiality and proprietary software things, I will not be able to take you beyond this, but I'll be able to explain to you as to how we use this and how do we do this. Since this session is also being recorded, I don't want to pass through this area and identify and show you how do we really connect these error codes with each bank and bring it to a global network. So this is again the channel of different solutions of a banking through which we do a transaction, fraud payment, channel customer analytics, credit and debit card program management, reconciliation, dispute resolution, cash forecasting, and open data access and streaming. So I will now move on. The slips that you are seeing are the 6 different slips that we can generate using admin mode of an ATM. So if you put the ATM into admin mode, you will be able to draw the 6 cards or the slips which will come from the ATM mode. The first one is before loading the cash. Journal, we call EJ, electronic journal input. Second one is after loading the cash. The third one is the switch balances, which is showing here. Fourth one is the bank server output. The fifth one is the ledger, which is showing how much transactions totally happened for the day in the admin mode. The sixth one is the difference of cash. So these are CBR copies which are uploaded by the technician who goes on ground and handles this ATM in any remote corner in India. Just showing you something on Bank of Baroda as an example of how a BNA scan copy is uploaded to a server for reconciliation and management while we connect this on an ATM network. So these are all admin values. This is not a customer slip. These are all admin values. If you go and see here, it is showing you how many notes of 2000 are there, how many notes of 500 are there, how many notes of 100 are there, how many notes of 50 are there in this ATM. So this is the admin mode report with which we identify this. This is just a sample for you to know how do we really attempt to end. And there are 2 kinds of services that we do on an ATM. One is called FLM, another is called SLM. FLM means first level service, which is EJ pull, change of cash replenishment, change of role, other things. And the SLM is a OEM based second level maintenance, which is done in order to move the ATM running up and running wherein ATM is open and every spare part of the ATM is worked on. This is something ERP wise module of ATM that we have built, which is based on key management, risk and recon, billing, NOC, FLM call center, MIS reporting, masters and daily intent, which is of our ATM. Let's come to big data of ATM. Now, big data, as I already explained, that we are drawing data from different ATMs across India and connecting this into one network to find out the size of these data and from where we analyze. Now, this is classification of different chains in India, like retail chains, insurance, microfinance, NBFC, and banks, which are governed by RBI, through which you can connect them to a network. We come to the final slides, wherein we are talking about 6 areas of artificial intelligence in ATM. These are the 6 areas in which we are working, and our systems are deployed, which works on forecasting of ATM cash demand. First slide, let me take you to the forecasting. Say, for instance, the deployment of ATMs across India, and you have a Diwali period or a Puja holiday period, wherein you see mad rush in markets. So obviously, it is logical that most of the people will go for buying material from different shops for which they will require cash, and they will all move into ATMs to withdraw the cash. So generally what we have seen is during holidays, you have 3x crowd on each ATM. On a general principle, if there is about 1,200 walk-ins in an ATM per day, you would see on that day 3,600 people walking into an ATM to withdraw cash, depending on the deployment of the ATM and location and region where it is being located. If it is very near to the shopping market, you will definitely see so many numbers. So how do we forecast as to how many people will come to that ATM, how much cash will they require for that day, and when will the ATM become empty? So you cannot run that ATM under without cash for a long time. So we have developed something called forecasting cash demand, which we are using time series regression model, in which, based on our experience of that ATM, this cash demand forecasting is done by the AI solutions, which calculate the cash that will be required for that particular day which can be a weekend, which can be a holiday, which can be a strike period, which can be a COVID lockdown. How much cash do you require in this ATM? System will generate 1 day before the report that is required to be loaded in that cache, in order to make sure that we do not load much of the cash, because there is dearth of availability of cash with bank also, to make sure that all 45,000 ATMs across India are filled with what is the minimum requirement for that day. And they also do not, completely go out of cash. So this is what we use, time series regression model, with which we do cash management of demand forecasting of ATM. Next is reconciliation management. This is a second solution. Like if there is a dim light sensor test, CS11A, 11B, and 11CS4, this is based on a debold or print on machine, in which this error will point out as to what really happened during reconciliation management of the ATM. So use this for reconciliation management. Use predictive maintenance of ATM machines. Now, there is a reactive maintenance, which we call yesterday's solution. There is a predictive maintenance, which is today's solution. Would you like to do or repair an ATM after that fails? Which means you need to put people to find out ATM is gone, and now you have to send somebody to repair that, or do you use a predictive maintenance? In the predictive maintenance, you predict that this particular ATM will be repaired in the next 7 days. So based on your models, you make sure that while you see that there is network connectivity issues in this location, there is a switch always going down, host is not reachable, or this particular machine is not being utilized for so many days, or repaired for so many days, you really know that there is an issue which is going to be cropping up in that. So we use predictive model, which for maintenance, and we give remote support, with which we deploy maximum number of alerts to that particular ATM, based on which the FLM and SLM are done on ground, and we make sure that ATM maintenance are kept up and running. Next is cybersecurity in ATM. We use different rise of attacks which are happening, DDoS attacks in ATM. So we really have, the hackers move, steal malware and send a malware to the system, control that ATM, try to deploy, and becomes vulnerable for our ATM to deploy the cache. So we use predictive models, identify that there are malware attacks already done in the ATM. We log the ATM, we make sure the cache is not dispensed to anyone, using our own proprietary software, which runs on cache out and jackpotting. So next is machine vision ATM cameras. There are cameras which are on the ATM route. Based on certain alerts, these cameras switch on and they start recording your feed. And these feeds are being passed on to mobile as well as tablets and mobile, walls, digital walls, through which the bank is able to immediately take the decisions. Level of analytics and AI we are doing is on facial recognition for security, which really records the emotion recognition, segmentation, image segmentation. Then we use identity verification, feature extraction, emotions that this person does. So right now there are ATMs which really know, and they recognize you by your face. They only dispense cash if the face values meet the PIN and 3 levels of authentication, after which the cash is even dispensed to you. I think this I like to end my session, and I'm open for all the questions that you have. And thank you all for cooperating and attending this session. I really enjoyed, and I will now look forward for questions, if any, from your side.
Participants, if you have any questions, you can please ask to the sir.
So I see the session was jam-packed for 90 minutes. And what I could deliver today is the experience and understanding of this particular subject for last so many years, about 20 years. And if it is a session where we can interact face to face, discuss, it would have been much better. But however, with the technological advancement, what we could today discuss between ourselves was really welcoming. And I thank each one of you. If somebody has question, please chat there. If not, I would like to end my session here. And thank you so much for offering this session. And I was really elated to meet you all in this webinar today. Thank you.
If there are any questions, you can ask. Otherwise, Ramkumar sir, you can wind up. You can conclude.
Yes, ma'am. Yes, ma'am. So thank you very much, sir, for your valuable discussion regarding your the ATM real-time consolidation. So what we have known a lot, what we have gained lots of information from you, sir. And we have also had the technical knowledge and the practical knowledge oriented this ATM, as well as the artificial intelligence, machine learning techniques, how we are going to integrate with Internet of Things, and the practical realizations oriented this particular work. And also we had a brief technical knowledge on so how far the neural networks, like artificial neural networks, convolution neural networks can be applied to various domains. So everything we had a brief exposure, and so every one of us will be coming in applying this particular concept in various applicational fields, and this helped us very lot in proceeding in various projects. So a good platform for a good exposure. Thank you very much, sir. On behalf of Sri Krishna College of Engineering and Technology and the Department of ECE, as well as AICTE, so I thank you very much, sir, so for this wonderful session, and thank you very much. Thank you. Thank you.
Thank you so much. Enjoyed you. Thank you.